This is a video on maximizing curvature. The question states, find the point on the curve at which the curvature is a maximum. And we have the curve defined by y equals e to the x. So first let's recall the formula for the curvature when we have a curve defined by y equals a function of x. And that's that the curvature k is equal to the absolute value of y double prime divided by the quantity 1 plus y prime squared all to the 3/2 power. So I need to find y prime and y double prime, which is quite easy when y equals e to the x, because the derivative of e to the x is e to the x, so y double prime is also e to the x. So I plug in, and I get that the curvature is equal to e to the x divided by 1 plus e to the x squared is e to the 2x, all to the 3/2 power. Now I want to find out when the curvature is a maximum. And to find a maximum, I take a derivative and set it equal to 0. To use the product rule instead of the quotient rule, I'm going to move this denominator up as a negative exponent and write this curvature function as e to the x times 1 plus e to the 2x, all to the negative 3/2 power. So now I can find the derivative by taking the product rule. The derivative of e to the x is e to the x times the second, 1 plus e to the 2x to the negative 3/2. And then I need the chain rule for the derivative of the second function. The derivative of 1 plus e to the 2x is 2e to the 2x. And note that e to the 2x times e to the x is e to the 3x. And then when I take the derivative of this power, I get a negative 3/2 times the 2 that I had from this 2x. And negative 3/2 times 2 is negative 3. And then I have the inside 1 plus e to the 2x, all to the negative 5/2 power. Negative 3/2 minus 1 is negative 5/2. So there's my derivative. I can simplify this by factoring. I can factor out an e to the x. I can also factor out a 1 plus e to the 2x, all to the negative 5/2 power. That'll help me out here. So I have my e to the x, the 1 plus e to the 2x to the negative 5/2 power, and when I pull a 1 plus e to the 2x to the negative 5/2 power out of 1 plus e to the 2x to the negative 3/2 power, I'm just left with a 1 plus e to the 2x to the 1 power, or 1 plus e to the 2x. And when I pull an e to the x out of e to the 3x, I'm left with an e to the 2x. So I have minus 3e to the 2x, and this second factor goes away because I pulled it out. So I can set this equal to 0 and solve. And note that e to the x is never 0, and 1 plus e to the 2x, all to the negative 5/2 power, is also never 0. So I can say that 1 minus 2e to the 2x, I just wrote that e to the 2x minus 3e to the 2x is negative 2e to the 2x. So 1 minus 2e to the 2x is equal to 0. And I can solve that. I can subtract 2e to the 2x, divide by 2, take a natural log, and then divide by 2 again. And I get that x is equal to 1/2 natural log of a half. I can simplify that. Natural log of a half is the same as negative natural log of 2, because 1/2 is 2 to the negative 1. And then I can pull this 1/2 as an exponent, and 2 to the 1/2 is the same as root 2. So I can say this is negative the natural log of root 2. Now let's find y. Y is equal to e to the x. So y is e to the negative natural log of root 2. I can bring the negative back in as an exponent and say this is natural log of 1 over root 2. And then the e and the natural log cancel. So I get y equals 1 over root 2. So now I'm ready to state my conclusion. I can say that the point on the curve where the curvature is a maximum is the point negative the natural log of root 2, comma 1 over root 2. And I'm done with the problem.